Okay, so today we're going to do other types of equations. They're going to be rational, so they're going to still have some radicals. They're also going to have fraction exponents. So we're going to learn something today called U substitution. So that way our equation will look something like a quadratic. So I'm going to show you how to use the U. It's going to go in place of an expression or a monomial, something like that. So let's try our first example. Now, just like yesterday, we need to isolate the radical first. So I'm going to move one of these over to the other side. So I'm going to actually move the cube root of x to the other side. And now I have 4x squared minus 4x plus 1 equals the cube root of x. Now again, in order to get rid of the root, we are going to raise both sides to the power that's equal to the index. Yesterday they were all square roots, so we squared everything to get rid of it. Today this one is a cube root, so to get rid of that, I'm gonna cube both sides. So let me raise both sides to the third power. That will cancel the root. And now I'm just left with 4x squared minus 4x plus 1 equals x. I now need to get it into standard form because it is quadratic, so I can factor it. So I'm going to subtract the x. 4x squared minus 5x plus 1 equals 0. I now need to factor this. Factoring is going to be the fastest way. So I'm going to just do guess and test because my factors of 4 are 4 and 1 or 2 and 2. And my factors of 1 are just 1. So 1 and 1. And I'm going to try 4 and x. So 4 and an x. And notice my middle sign is negative and my end is positive. So I know those are both negative, negative. So I did that guessing and testing. You can also factor by grouping. I need my x's in here. So, I already have an x on that one. So now I'm just going to set each factor equal to 0. So 4x minus 1 equals 0. And x minus 1 equals 0. Add the 1. 4x equals 1. Divide by 4. And my first solution is x equals 1/4. Here, add 1, and x equals 1. Now, what's nice about the cube roots, we don't need to check those, okay? Because remember, when we were doing cube roots, if I do the cube root of 8, I get 2. And I can also do the cube root of negative 8 and get negative 2. So when your root is an odd number, like a 3 or a 5, we don't need to check because we don't have to worry about the negative answers. They're going to work. Everybody good on that?
So don't check, do you?
You don't have to check on the cube roots.
That was the hardest part.
Okay. But if it's an even root, like a square root or a fourth root, we do have to check. Okay? But cube roots, you don't. So next one, I can do it. I'm going to show you just by factoring it as is, and then I'm going to also show you how to solve this using U substitution. So I could actually factor this by guessing and testing. I'm going to look for the factors of 12 and the factors of 2. So I know my factors of 2 are just going to be 1 times 2, and I know my signs have to be different. And then my factors of 12 that would go here are either going to be 1 times 12, 2 times 6, or 3 times 4. It's actually going to be 3x times 4x. And then I'm going to put a square. Nope, these signs are wrong. I need negative, negative. Okay, so now I highly recommend after you think you have it factored to double check the outer and the inner. So this gives me negative 8x squared The outside gives me negative 3x squared. When I add them, I do get the negative 11x squared. So this is the faster way to do this. Even though it's to the fourth root, or to the fourth power, I could still split up x to the fourth into x squared times x squared. Now I need to set each factor equal to 0. So 3x squared minus 2 equals 0. 4x squared minus 1 equals 0. Add the 2. You had a question like this on the test. 3x squared equals 2. Just this part of the solving. Divide by 3. And now I get x squared is equal to 2/3. I need to solve for just x. So I square root both sides. And I get x equals plus and minus the square root of 2/3. Now, remember, I can pull this apart, give each one its own little radical. Remember, we can never leave a square root in the bottom, so I have to rationalize. So this final answer becomes plus and minus square root 6 over 3. Now I have to do the other one. Add the 1. 4x squared equals 1. Divide by 4. X squared equals 1/4. Square root both sides. And x equals plus and minus 1/2. Because I square rooted the 1 individually and the 4. So that one I don't have to rationalize because the whole thing came out. Now, when your original equation is a polynomial, notice this is a trinomial, again, we don't need to check. So my two answers here are x equals plus and minus square root 6 over 3 and plus and minus 1/2.
Wait, why don't we check this one?
Because it's a polynomial. There's no radicals and no fractions. So when it's just a polynomial, like a trinomial, we don't need to check. Now, a clue here, when it's a polynomial, see this exponent of 4? This tells me how many answers or how many solutions I should be getting. So it's got an exponent of 4, so I should be getting 4 solutions when I'm all done. Notice what I got. I got 4 answers. I got positive and negative square root 6 over 3 and positive and negative 1/2. 4 answers. So again, if it's a polynomial, you don't need to check. Now, I'm going to show you and teach you the U substitution. Now, the way that I did it, this is the easier way. If it's not that complicated, just factor it as is. The other way to do it is to turn it into a quadratic formula without a power of 4. And the way that we're going to do that, let me rewrite the original. 12x to the 4th minus 11x squared plus 2 equals 0. I am going to introduce a new variable, and my variable is going to be called the letter u, and it's going to represent the variable that's in the middle term. So I'm going to let u equal x squared. So if u equals x squared, then u squared equals x to the 4th. So now what I'm going to do is I'm going to write my equation as 12u squared minus 11u plus 2 equals 0. Now I don't have a 4th power to deal with. And I'm going to factor it the same way though. So now it'll just become 3u minus 2 and 4u minus 1. It's a simple quadratic. Again, solve it the same way. Set each factor equal to 0. Add 2. 3u equals 2. Divide by 3. Now, u equals 2/3. Let me do this one. 4u equals 1, divide by 4, and u equals 1/4. Now, the instructions aren't going to say solve for u, it's going to say solve for x. So now what I have to do is take what I set u equal to up at the beginning and plug back in the x squared. So now, where I see u, I'm putting x squared. And now I have the same thing that I just did over here, and I solve it the same way, and I get the same answers. Now, I highly recommend when it's simple like this to do how I did it the first time. However, we're going to get some expressions in here, and your u value is going to be like a binomial, and it's going to get more complicated. For those problems, I would do the u substitution. Okay? For the easier ones, do this left side. All right, so for 1, notice we have x plus 1 raised to the 2/3 power minus x plus 1 to the 1/3 power minus 2 equals 0. Again, my middle term is what u is going to equal. So I'm going to let u equal x plus 1 to the 1/3 power. So now, right now I have minus u minus 2 equals 0. Notice over here, this part is what u is, but then I square it because it has the exponent of 2. If you want to think of it as x plus 1, and separate that 2/3 into 2 times 1/3. So you've covered, and u equals this part of it, and then you just put the square there. So now I have a simple quadratic that I can factor. So the factors of -2, that when I add them give me -1, and this will be u minus 2 and u plus 1. I solve each of the factors. Add 2, u equals 2, subtract 1, u equals -1. Now, again, they didn't ask me to find the value of u, they asked me to find the value of x. So now, where I see the u, I'm going to replace that with the x plus 1 to the 1/3 power. So let me go and put that in. So x plus 1 to the 1/3 power, x plus 1 to the 1/3 power, and now it equals 2, and it equals -1. Now, again, remember, x plus 1 to the 1/3 power is the same thing as saying x plus 1's cube root. Does that make sense? Because remember, a fraction exponent means that it's got a root. So in order to get rid of the 1/3 power, I am going to raise both sides to the 3rd power. Because 1/3 times 3 becomes a 1. So now I just get x plus 1 equals 2 to the 3rd, which is 8. Here again, when I multiply 1/3 times 3, the 1/3, the x plus 1 comes out. -1 to the 3rd power is -1. Now I need to solve, and this is going to give me my x values. Subtract 1. My first solution is 7. Subtract 1. My next solution is -2. I don't need to check. This was a polynomial. Next one. Remember this 5x squared minus 6 to the 1/4 power is the same thing as saying the 4th root. So remember yesterday we raised both sides to a power. That's the same as the index. So I'm going to raise both sides to the 4th power. 1/4 times 4, this just becomes to the first power, so it frees up the 5x squared minus 6. This side becomes x to the 4th. I now need to put this into a standard form that I can factor. So I'm going to move the 5x squared over, because I'm going to try to keep my large exponent positive. X to the 4th minus 5x squared, add the 6. X to the 4th minus 5x squared plus 6 equals 0. Now, notice my power is not a square, so I have options here. I could either factor it as is, or I could do the u substitution again. So if I factor it as is, my factors of x to the 4th power, I'm going to break it into an x squared and an x squared. My factors of 6, that when I add them give me -5. And that's going to be -2 and -3. I now set each of the factors equal to 0. And I solve for x. Add 2. X squared equals +2. Add the 3. X squared equals 3. Again, I don't want x squared. I want just x. So I square root both sides. This gives me x equals plus and minus the square root of 2. X equals plus and minus the square root of 3. Now, this was an even root, so I really would have to check this one. Just know that this one would be a bit challenging without a calculator, so know that only the positive roots are going to work on this one. If I give you something like this on the quiz, I will let you know that you could skip the check, okay, if it's going to be too hard to do without a calculator, because you're not using a calculator for the quiz. So the only answers here are going to be x equals the square root of 2 and x equals the square root of 3. So we would throw away the negative answers on this one. They would fail when we do the check. Now, we could also do a u substitution here, just to practice it when it's kind of basic. So if I rewrite the problem again, it was 5x squared minus 6 to the 1/4 power equals x. So here, I could do a u substitution after I get rid of this, and I get 5x squared minus 6x, or minus 6 equals x to the 4th. Standard form is this. This is where the u substitution comes in. I would let u equal x squared. And again, I would factor this into u squared minus 5u plus 6 equals 0. So again, the variable that's in the middle is what you're setting u equal to. So then factor it the same way. U minus 3, u minus 2. Set each factor equal to 0. Add 3. U equals 3. Add 2. U equals 2. Again, now substitute back in x squared for the u. And now I solve it the same way I just did over here, by square rooting both sides. Next one, notice it's already isolated for us, so all we have to do is cube both sides. So raise this side to the 3rd, this side to the 3rd, it'll cancel the radical, and I'm left with 2x equals 5x plus 2. Move the 5x. Negative 3x equals 2. Divide by negative 3. And x equals negative 2/3. It's a cube root, so I don't need to check. So I'm done. Next one, same thing. I'm just going to cube both sides because it's already isolated. I'm left with 3x squared minus 9x plus 8 equals x. I need to get it in standard form. Subtract x. 3x squared minus 10x plus 8 equals 0. I now need to factor the trinomial. Now, if you want to do factor by grouping, you can. 3 times 8 is 24. Factors of 24 that give me 10. That would be 6 and 4. Or we could go right into the guessing and testing. Factors of 3 are just going to be 3 and x, or 1x. And then the factors of 8 are going to be 4 and 2. And they're both negative. Now you could also have done the grouping. You would get to the same answer that I have right now. Now I set each of the factors equal to 0. Solve for x by adding 4. 3x equals 4. Divide by 3. And x equals 4/3. Add 2. And x equals 2. Again, I don't need to check. It was a cubed root. So both of my answers are good. Next one. Again, remember this x, 3x plus 7 to the 1/3 power is the same thing as saying the cube root of that. So again, I'm going to isolate it. So I'm going to move this one over to the other side. Add it to both sides. So then I get 3x plus 7 to the 1/3 power, 4x plus 2 to the 1/3 power. And again, I need to get rid of that 1/3. So I'm going to cube both sides, just like I would have done if it were a radical symbol. So I'm going to raise both sides to the 3rd power. 1/3 times 3 just becomes 1. So then it's 3x plus 7 equals 4x plus 2. Need to get my like terms together so I can subtract 3x. 7 equals x plus 2. Subtract the 2. And 5 equals x, or x equals 5. Again, it was a cube root. So again, I don't need to check. Next one, it's already isolated. So remember, to get rid of that 4th root, we're going to raise both sides to the 4th power. So this would just cancel. And I get 3x plus 1. 1 to the 4th power is just 1. And now I solve. Subtract 1, 3x equals 0, divide by 3, and x equals 0. This is a 4th root, so I do need to check it. It's even. So 3 times 0 plus 1. 3 times 0 is 0. 4th root of 1 is 1. 1 equals 1. It checks. So 0 is a good answer. Next one is going to be the same thing. I need to get rid of that radical, so I'm going to raise both sides to the 4th power. So 4th power here, 4th power here. cancels that. I'm left with x squared plus 6x. 2 to the 4th power is 16. Move the 16. X squared plus 6x minus 16 equals 0. I need to find the factors of negative 16, that when I add them I get 6. And that's going to be x plus 8 and x minus 2. Set each of the factors equal to 0. Subtract 8. X equals negative 8. Add the 2. X equals 2. Now this was a 4th root, so I do need to check it. So x squared plus 6x equals 2. When I plug in negative 8 squared, 6 times negative 8, I get 64 minus 48, and this is a 4th root. So I get 16. The 4th root of 16 is 2, so it checks on that one. Plug in the next one. 2 squared plus 6 times 2. And again, 4th root here. So 4 plus 12, and I get the same thing. 4th root of 16 is 2. 2 equals 2. This one also checks. So they're both good. Next one, same thing. Again, it's just like a 4th root, but it's a fraction. So we solve it the same way. I'm going to raise both sides to the 4th power. So this cancels, and I'm left with 3x squared plus 52x, 4 times 4 times 4 times 4, 16 times 16 is 256. Move the 256 over. So it's going to be all set to factor. 3x squared plus 52x minus 256 equals 0. It's kind of big. So it's going to actually factor into, and you can do by grouping however you want to do it. It's going to factor into, I'll put a 3x and an x. And then the factors of 256 that I'm going to use are 64 and 4. It doesn't matter how you get there. If you want to do the grouping, guess and test. But those are the factors that will FOIL back to that. So 3x plus 64 equals 0. X minus 4 equals 0. Subtract the 64. 3x equals negative 64. Divide by 3. And x equals negative 64 over 3. Over here, add the 4. And x equals positive 4. Now this was a 4th root, so we would need to check it, but they both do work. If there's time, I'll go back and check it. Let me just get a couple more examples in here. Next one is a polynomial. Again, you could either do U substitution or you can factor it as it is. So if I just factor it as it is, factors of 4 are going to be 2 and 2, or 2x squared. And then my factors of 3 are going to be 3 and 1. So I'll put minus 3 here, minus 1 here. In this case, it didn't matter because they were going with the 2 and the 2. So now that I factored that, now I set each factor equal to 0. Solve for x by isolating first. Divide by 2. X squared equals 3 over 2. Remember, you got to square root both sides. So x equals plus and minus square root 3 over square root 2. I can pull it apart. I need to rationalize. So multiply top and bottom by root 2. So final answer here is plus minus square root 6 over 2. Now I need to solve the other one. Add 2. 2x squared equals 1. Divide by 2. X squared equals 1/2. Square root both sides. And I get x equals plus and minus square root 1 over square root 2. Square root of 1 is just 1 over square root 2. Rationalize. So final answer, square root 2 over 2 plus minus. So 4 answers. We have this one and this one. It was a polynomial, so I don't need to check. Again, you could still do the U substitution if you want, but I think these are a lot simpler just to do it this way. Okay. Next one. This one I need to get rid of the fifth root. So I'm going to raise both sides to the 5th power. So this cancels. This just gets rid of the denominator. So now I have x minus 3 squared is equal to 4x. I need to FOIL that x minus 3 squared. It becomes x squared minus 6x plus 9 equals 4x. I need to move the 4x over. X squared minus 10x plus 9 equals 0. And now I factor. Factors a 9 that give me negative 10, x minus 1, x minus 9. Set each factor equal to 0. And solve. Add 1. First answer is x equals 1. Second answer is x equals 9. This was a 5th root. We don't need to check. So both answers are good. 2 more examples. And again, it's just repetition. All right, let's see if we can get through it. All right, so again, we need to get rid of the root. I want to raise both sides to the same power. So in order to get rid of the 4th root, I'm going to raise both sides to the 4th power. Notice when I multiply over here, I'm doing 1/2 times 4 over 1. This simplifies, and what comes out is x squared. On the side over here, the 4 goes to the 3, and then when I multiply it to the 3/4, this just becomes x to the 3rd. Now I'm going to get it in a form where I could factor. And I get 81x cubed minus x squared. I'm going to factor out a GCF of x squared. And now set each factor equal to 0. X squared equals 0. 81x minus 1 equals 0. X equals 0. Add 1. 81x equals 1. Divide by 81. And x equals 1 over 81. And I'm done. Last example, again, a U substitution. I'm going to let U equal the middle term, which is the 2x minus 1 to the 1/3. So right here. So this one becomes U squared plus 2u minus 3 equals 0. I can factor this into u plus 3, u minus 1. Going to solve for u. Set each factor equal to 0. Okay, so we're going to subtract the 3, add the 1. I now have the value of u, but it did not ask me to solve for u. It asked me to solve for x. So now I'm going to substitute it back. So 2x minus 1 raised to the 1/3 power equals negative 3. 2x minus 1 to the 1/3 power equals 1. And now I'm going to solve for these. Again, I need to get rid of my 1/3 power, so I'm going to raise both sides to the 3rd power. So this would now cancel out. 2x minus 1 equals negative 27. And now I'll solve for x. 2x equals negative 26. Divide by 2, and x equals negative 13. Over here, 2x minus 1 cancels out and comes free. 1 to the 3rd power is 1. We will add 1 to both sides. 2x equals 2. Divide by 2. And my second solution is x equals 1. Again, we do not need to check these. X equals negative 1/3 and x equals negative 1 or positive 1. Your homework is 51 through 71 odd.